Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of similar proportionality. This is standard 8.3a in the great state of Texas, and we are using item number 32 off the 2021 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have two triangles, and we don't even have the measurements on all three sides. We just have the measurements for side AB and AC, and then DE and DF, and all of our answer selections are numbers, so we can't even use whatever this side is over here. Those just aren't going to work. So let's label this big and small, because that is going to be very important when we're trying to compare within different shapes. Is we're matching up the big and the small. So let's see what that looks like. Let's start with F. So F is going to be 7 over X, right? So 7 is going to be the base on the big, and X is the base on the small. Okay, so that works. But what that means is we need to have in our other side of our proportion a base on the numerator and a small in the denominator there. So since we decided bases can be a numerator, let's see what we had. We had 4 over 6, and 4 is from our small, and then 6 is from our big. So at least the 4 and the 6 do match up, but that's incorrect. If we would have flipped those, if we would have had 6 over 4, then we would be good. So we can't use that. And that's kind of tricky because all the numbers do match up, but you need to have, if you establish on the left side big is your numerator, you need to have big in your numerator on the other side. Let's check G. 4 over 6. Okay, so we are going the diagonal for small and the diagonal for big. Okay, so that works. That's fine. Those two match up. We're going across shapes. Those two are corresponding signs, which means I'm going to need it on this side since we established the small in the numerator. Let's do that on the other one, and the big in the denominator. And so I've got X over 7. X is my small, and it does match up with 7. That's my big. All right, so I'm looking like G might work for us, but let's just double check, obviously, see what's wrong with H and J, because they all use 6, 4, X, and 7, right? There's only so many ways you can do it wrong. Let's check 6 over 4. All right, so I've got my diagonal for my big, looking at H now, and my diagonal for my small. So they are corresponding sides. We're going big to small, which means I'm going to need in my numerator big, and I'm going to need a small in my denominator. And look what they've got here. They've got X over 7. X is not big, it's small. And 7 is not small, it's big. And so you see how this doesn't match up right here. It needs to be big to big, and it needs to be small to small, if that's what we established. So once again, if I were to flip those, I would be good. But we didn't. And J, I'm pretty sure is going to be wrong. At least I hope it's going to be wrong, because G already looks correct. But we need to go through the process. So 4 over X. Okay, so we're actually staying within the same shape on this one. That's fine. So this is a small to small. You see my 4 and my X, and that's fine, which means over here we need big to big. All the other ones we went across the shapes in our fractions. We can stay in the same shape in the fraction, but it needs to be corresponding sides, right? So 4 corresponds to 6, and then my X corresponds with 7. So that would work, but look what they give us. They give us the 7, and they give us the 6. Right numbers, but they flipped them. So that's why this one is incorrect. And so my answer here is going to be G.